Alright, so here's another example where we're asked to verify an identity. Obviously in this problem we want to start with the most complicated side, which is going to, I think, fairly obviously be the left side here. The right being one term and the left being the product of two binomials. Now, looking at this, there's a couple things that come to mind to me. One, obviously we have a lot of different trig functions. We have 3 different ones. And so your first thought might be to change these all to cosine and sine. There's nothing wrong with that, and you can go ahead and do it. I'm going to wait just because I just want to stay away from having to multiply all these different fractions together. So I'm going to kind of multiply them together. I'm going to use the method that I have mentioned before, just the generic rectangle method. It works for both factoring and for multiplying back out. You can, of course, just FOIL these, and that'll work just as well. I'm going to write out here, I have secant, okay, minus tangent, and then right over here, I lost my other pen. Oh well, I'll just do the rest in pencil, I guess. I have cosecant, okay, and 1. So if I multiply this side of the rectangle times this side of the rectangle, which I can break up into these smaller rectangles and add them up, that'll give me the product of these two binomials. Okay, so I multiply these two together, and I get cosecant times secant. Multiply these two together, and I get secant. Multiply these two together, and I get negative. Now this one here, I'm going to actually do a little side work here. I know that tangent can be rewritten here as negative sine over cosine. I said I wasn't going to do this, but I'm noticing here that I have sine over cosine and I have a cosecant, which I know is just can be rewritten as 1 over sine. Okay? And so I can actually just cancel these out, which just leaves me with negative secant. And that's what I'm going to put here. Again, it's up to you where you want to do this stuff. I just think it's in the interest of room and simplicity, that was the best option for this particular problem. There's another reason, and hopefully you're seeing it right here why I did that. And then the last box is just going to be negative tangent times 1. Which is just negative tangent. Now hopefully you noticed here that I can cancel those two boxes. And so I can rewrite this whole thing here as cosecant theta secant minus tangent. Okay. All right, so moving on here, what I'm going to go ahead and do is now I'm actually going to go ahead and change everything to sine and cosine. So I can rewrite the cosecant here as 1 over sine. And since this is going to be 1 over cosine as well, I'm just going to go ahead and throw that cosine on the bottom. Okay, 1 over sine times 1 over cosine is just going to be 1 over sine times cosine minus sine over cosine. Okay. Now, obviously, here I have 2 terms, and I only have 1 for my original, or what I'm trying to get here, the cotangent. So what I'm going to go ahead and do is I'm going to multiply both top and bottom here by sine to give myself a common denominator. Okay? And then I can add these up. And hopefully what you're noticing here is I'm going to get a sine squared, and I have a 1 minus sine squared, so that's looking pretty good to me. So what I end up with then is I have my common denominator. I should be putting equal signs here. So this is going to equal 1 minus sine squared over sine cosine. Okay. So I'm looking up here and I see a 1 and I see a sine squared, so I'm thinking, oh, that's a Pythagorean identity, which is just equal to cosine squared over sine cosine. Well, I can cancel my cosine down here with one of the cosines up top. Then I'm left with cosine over sine which is an identity. It's just cotangent.